Ever think that a genius brain is just bigger or maybe faster? Well, what if I told you that's not really the whole story? The real secret, it turns out, is something way more elegant. It's all about efficiency. So let's dive in and take a look under the hood at how these high IQ brains actually work. You know those people, right? The ones who just seem to get it. They can look at a crazy complex problem and just see the answer. They spot patterns nobody else does. You're left wondering, how do they do that? Well, that's exactly what we're going to get into. We're going to peel back the layers and look at the actual machinery inside the brain that makes it all happen. Okay, so before we can talk about a high IQ brain, we kind of have to figure out what intelligence even means in the first place. And trust me, that's a question researchers have been wrestling with for like over 100 years. And that brings us to something called the G factor. It's a pretty cool idea. Basically, scientists notice that people who are good at one thing, like, say, verbal puzzles, also tend to be good at totally different things, like navigating with a map. It's like there's this underlying general intelligence, the G factor, that boosts performance across the board. And figuring out what G really is, that's the mystery we're diving into today. But of course, it's not that simple. Science loves a good debate, right? So on one side, you have the idea that G is a real thing, a central powerhouse for intelligence. But then there's another idea, the process overlap theory. And it says, hold on a second. Maybe G isn't a cause at all. Maybe it's just what it looks like when different tests all happen to use the same basic brain tools, like working memory. So G is just the statistical shadow of that overlap, not the source of the light itself. Okay, let's break it down even more. Think of intelligence as having two flavors. First, there's crystallized intelligence. This is your mental library, all the facts, figures, and skills you've stored up over the years. Then you've got fluid intelligence, and this is the interesting one for us today. It's your raw ability to solve a problem you've never, ever seen before. It's pure, on-the-spot reasoning, and that's what we're really going to focus on. All right, so if fluid intelligence is all about tackling new problems, what's in the brain's toolkit for the job? Let's pop the hood and look at the software that makes this intelligence engine run. This is what we call the brain's executive functions. Think of them as your own internal management team. You've got planning, which lays out the strategy. Attention control, the team member who keeps everyone focused on the task at hand. Inhibition is your gatekeeper, blocking out all the distracting noise. And the whole time, working memory is like the whiteboard in the room, holding all the important info where everyone can see it. A truly intelligent brain is one where this team works together flawlessly. Now, out of that whole team, working memory might just be the MVP. It's literally like the RAM in your computer. It's the mental scratch pad where you hold and shuffle around ideas. And just like with a computer, the amount of RAM you have is a huge bottleneck. It's no surprise, then, that working memory capacity is one of the single best predictors of fluid intelligence we found. Okay, so we've got the what, the cognitive software. Now let's talk about the where. Where is all this heavy lifting actually happening inside the brain? Yeah, it turns out intelligence doesn't live in just one spot. It's all about the network, the connections. The big one is called the perio-frontal integration theory, or PFIT for short. Just picture a superhighway for information, connecting the front of your brain with the back. And on that highway, you've got this special task force called the multiple demand system. Whenever things get tough, I mean any kind of tough cognitive task, this network lights up. It's basically the brain's flexible, all-purpose problem-solving squad. And here's the absolute key takeaway. It's not about the size of any one part of the brain. It's all about the efficiency of the whole network. A high IQ brain is one where these different areas talk to each other quickly and cleanly, with less static on the line. They get the job done using less energy. That word efficiency is what this all comes down to. So that begs the million-dollar question, right? What exactly makes these networks so efficient in a high IQ brain? How does that efficiency advantage actually look when the brain is processing information in real time? Now you might be thinking, okay, I get it. A smarter brain is just a faster brain. You know, like upgrading your computer's processor. It just runs faster. Simple. But is it really that simple? Well, turns out, not quite. The advantage isn't just about being faster at everything. It's way more specific and, honestly, way more interesting than that. The real speed boost only kicks in during the more complex, higher-order stages of thinking. And this is where it gets really fascinating. Get this. People with higher IQs are often a little bit slower
at the very initial stage of just taking in information from their senses. It's almost like they're taking a tiny extra moment to make sure they get a clean, high-fidelity signal. But then, and this is the key, they are way faster at the next step, making sense of it. Brainwave studies show it. There's this signal, the P300, that basically marks the aha moment. In high IQ brains, that aha happens much, much sooner. So they're faster where it counts, figuring out what matters and tossing out the junk.
Okay, let's put all these pieces together. We're going to zoom in on one core process that shows this high-performance engine in action. It's called attentional integration, and it's basically the step-by-step playbook for how your brain builds a solution to a hard problem.
And this quote from the research really just says it all, doesn't it? You don't tackle a 1,000-piece puzzle by staring at the whole box. You have to break it down. Your brain does the same thing. It takes a big, messy problem, breaks it into bite-sized pieces, focuses on each one, and then stitches it all back together.
The jigsaw puzzle analogy is perfect, right? You're not just staring at a mountain of pieces. What's the first thing you do? You segment. You pull out all the edge pieces. Then you give those pieces your focused attention. After that, you start to bind them, linking up matching colors and shapes. And finally, you integrate them into the solid frame. Well, your brain follows that exact same four-step process for any complex abstract problem. And this is where that efficiency advantage we've been talking about really comes into play. The high IQ brain is like an Olympic-level puzzle solver. Its attention is super flexible. It can zoom in on one tiny detail, then zoom right back out to see the whole picture. That task force, the multiple demand network we talked about, it gets called in with more force. And their working memory, their mental whiteboard, can hold more pieces at once, making it way easier to see how everything fits together. So if you take one thing away from all this, let it be this. Intelligence isn't a thing you possess, like a trophy on a shelf. It's a process your brain performs. It's this active, dynamic dance of breaking problems down and building solutions up, all driven by a super efficient network.
Which, of course, leaves us with one last pretty exciting question. If intelligence really is a process, a set of skills like focus and mental juggling, does that mean we can get better at it? Can you actually train your brain to be more efficient, to be a better problem solver? Well, that's the big question researchers are tackling right now.